All right, 9.1. Okay, so this problem comes from, it actually comes from the notes, not the homework. So I think this is number of oil changes per year, and this is the MSRP value of the car. Anyway, so I want to see if there's a relationship between those two things. And so what I do is I get on my calculator, and I go into the stat button, and edit. I got to get these numbers into the calculator. So same as when you're doing one variable stats, these numbers have to go in. And so you take all of this first list of numbers, 4, 3, 7, 5, 6, 2, 1, and you put those in list 1. Okay. And then 28.1, 15.2, 34.5, 27, 18.5, 20, and 15, you put those in list 2. So this is like the first time we've used list 2, but you need both lists. Okay, that way the calculator is going to know they come from two separate lines on the paper. So this is kind of like this is the X values and that's the Y values. Okay, and it's got to match up. If I accidentally don't type in one of these numbers, if I skip out one of the numbers on the second list, so there's like 7 numbers on the first list and 6 numbers on the second list, when I go to actually do some work on this, the calculator is going to say dimension mismatch because they don't, you know, it's got to have matching. This is one person, 4 oil changes per year, car is 28.1 thousand. Okay, so you've got to have them matching up. So be really careful about putting them all in. Okay, so once I get them in, then I go stat and test. And then it's just about the last choice. It's second to last choice, I think, and my calculator's choice E. Okay, LinRegTTest. So I hit that, and then it comes back and it says X list. And it's already got L1 written there. Well, that's good because that's where I put that. So if for some reason you didn't put it in list 1, you now have to tell it where you put it. That's why it's best to put it in list 1. And then under that it says Y list, list 2. So that's where I put that. And then under that, it says like frequency 1. It says something that looks like B and P and stuff that looks like I'm doing some sort of hypothesis test. I am actually doing a hypothesis test. It's testing to see whether or not these things count as being on a line or not. But it doesn't actually matter which one of those you choose. So I just breeze on past them. Once I get into LinRegTTest and check that it says L1 and L2. And then RegEQ, I skip that as well. It's blank and I leave it blank. All the way down to calculate. So basically I go into LinRegTTest and then just straight down to the word calculate. Don't mess with anything. All right, and then it says a lot of stuff on here. First it says y equals a plus bx. I'm going to need that for 9.2. And then eventually it tells me what a and b are actually equal to. And eventually it comes down to r equals 0.703. Okay, is it correlated? Well, that was the R from like what I was doing in the previous video. And I have to find my R table. Okay, and what I do is I count up the number of points I had, data points, 1, 2, 3, 4, 5, 6, 7. And I go down to 7. It doesn't even say degrees of freedom. It just says N. So I just go straight down to 7. And it says 7.54. I'm not even looking at over at the 0.01. 0.05 is the industry standard, so I'm just doing that. Which means, I'm going back to that number line I had, and here's 0, and here's 1. The cutoff is at 0.754, and this doesn't make the cutoff. That's just too bad. Even if it's close to the cutoff, nope, this is not correlated. If something's not correlated, you're basically done with the problem. Nobody's going to ask you of a line of something that isn't even correlated anyway, so you would just be done. But this problem, maybe there's a way I could fix it up. It doesn't look that bad. I mean, most people with expensive cars get more oil changes, and people with cheap cars don't get so many oil changes. So maybe somebody doesn't fit here. And if I was really trying to be super careful about this, maybe I'd graph and look for an outlier. Yeah, but this is one of the cheapest cars here, and they're getting like 6 oil changes per year. You know what? I'm going to take them out. Okay, if you are going to delete an outlier, you have to be sort of careful. You know, I mean, not really. You'd probably have hundreds of points and maybe only one or two outliers. But let's just say I can get away with deleting one. So I go back into Stat, Edit, and I go over to the 6 and delete that. Okay, and then the one that matched up with it was the 18.5. I also delete that. So I'm not going to get dimension mismatch because I've just deleted. All right, now I've just got 6 data points because I deleted one of them. Stat, tests, LinRegTTest, still says list 1, list 2, cruise on past everything down to the word calculate. R is now 0.9077, so 0.908. That sounds like a good number. 0.908. Okay, is that good enough? There's 0 there. There's 1 there. There's my cutoff in here. Actually, my cutoff just changed because I deleted something. So forget n equals 7. I deleted that. Now I'm on n equals 6. And the cutoff for that is 0.811. Yes, it clears the cutoff. It's in here. Okay, yes, this is correlated. And that's all you have to do for 9.1.